Question 10. The volume v centimetre cubed of a box of height x is given by this formula. X has to be between 0 and 5. Find dv by dx. So 4 lovely easy marks for a last question. Before we differentiate, we need to multiply this out. So v equals 4x, and then it's 5 minus x all squared, which means 5 minus x multiplied by itself. A lot of people just square the 5 and square the x. Really silly mistake. You have to multiply this out. You should be able to do it in your head. X squared minus 5x minus 5x is minus 10x plus 25. That's the result of expanding 5 minus x squared. We still need to multiply all that by 4x. So that's 4x cubed minus 40x squared plus 100x. So when we find dv by dx, multiply by the power, reduced by 1, 12x squared minus 80x plus 100. So that is your expression for dv by dx. For b, it says hence, so using what we've just done, find the maximum volume of the box. All that's asking you to do, despite it maybe looking like it's a lot for 4 marks, you just have to make dv by dx, the derivative, equal to 0, because maximums and minimums are when the gradient is 0. So you need to solve it for x to get the gradient to 0, and then do a little bit more, but we'll talk through that in a minute. So for part B, let's put that here. So that's dv by dx. We need to have 12x squared minus 80x plus 100 equaling 0. Like, you get 1 mark for that straight away. To solve that, it's a quadratic. We'll factorise, but before we do, we'll simplify this because there's a factor of 4 in all of these. So dividing both sides by 4 gives us 3x squared minus 20x plus 25 equals 0. It's now much easier to factorise, I think. 3x, x, two things that multiply to give 25. It's either going to be 1 and 25, which it's not, or 5 and 5. That would give you 15x, that would give you 5x. We want minus 20, so minus 15x and minus 5x gives you minus 20. Double check that minus 5 times minus 5 gives you this number here, which it does. So x equals positive 5 over 3, or x equals 5. Before we finish the question, there's a little bit more to do. We first need to realise that x has to be between 0 and 5. It's not allowed to be 5. So that means x is 5 over 3. The question is not finished though, because we need to find the maximum volume of the box. All we've done is found the value of x, i.e. the height of the box, for the maximum. So we need to substitute this back into this volume formula. So this is still for part B. V equals 4x, so that's 4 lots of 5 over 3, multiplied by 5 minus 5 over 3, all squared. And if you type that all into your calculator, be careful. It's 74 point something, hang on, 74.074. Leave it as a fraction if you'd like, centimetre cubed. So this answer here is the final answer for part B. This was part A. This here is the final answer for part B. It's the maximum volume. The next part, part C, is just a couple of marks. Use calculus to justify that the volume that we've found is a maximum. Now, if you want to find that it is a maximum, what you need to do is you need to find the second derivative and substitute your value for x that you got in, and it should give you a negative value. Remember, it's always the opposite of what you think. So if I get my little eraser here and we dispose of this side, hope you had that down. Gone. Part C. Try and write small. Right, you need d2v by dx squared. That's the second derivative, and all you have to do is differentiate the first derivative. So multiply by the power, 24x, take away 80, And that is what happens when you differentiate this bit. So we need to let x equal 5 over 3. And when we substitute in there, we'll get 24 lots of 5 over 3 minus 80, which is going to give me 120 over 3. I think that's going to be 120 over 3. 40 minus 80, which is negative 40, which is negative. Therefore, it's a maximum. If you're not sure as to why negative values of d2 in the second derivative gives a maximum and positive values gives a minimum, then just go and ask me or somebody else why. I won't go through it here, but it's, if you just remember, it's the opposite to what you think. So that's A, B and C, 10 marks. That's the difference between a grade. Quite easy for the last question.